Hello friends, welcome to my YouTube channel Chemical Adda. Please watch this video till the end to learn about the Ponchon Savarit method. In this video, we will discuss the third part of the Ponchon Savarit method. In the first and second parts of this video, we have already discussed how can apply the Ponchon Savarit method to the rectifying and stripping section. If you haven't seen first and second part, I highly recommend watching it first. The link is in the description. Now, in this video, we will discuss the next part, which is the Ponchon Savarit method for the complete fractionator. So, first let us write material balance and component balance equation for the complete fractionator, or envelope 2. Hence the total material balance can be written as F is equal to D plus W. And the component balance can be written as F into ZF is equal to D into ZD plus WXW. Then enthalpy balance equation, in the absence of heat losses, can be written as F into HF is equal to dQ dash plus W into Q double dash. From these three equations, let us find out the equation of straight line, like rectifying and stripping section. So, let us eliminate the value of F from equation 2, by putting the value of F from equation 1. Hence equation 2 becomes. After solving the equation, we get. After rearranging the term, we get D by W is equal to ZF minus XW divided by ZD minus ZF. Similarly, let us eliminate the value of F from equation 3 by putting the value of F from equation 1. Hence equation 3 becomes. After solving the above equation, we get. After rearranging the term, we get D by W is equal to HF minus Q double dash divided by Q dash minus HF. So, after comparing equations 4 and 5, we get D by W is equal to ZF minus XW divided by ZD minus ZF, which is equal to HF minus Q double dash divided by Q dash minus HF. Hence from material balance, component balance and energy balance, we get equation of D by W. So this equation shows the equation for a straight line on the HXY, that is enthalpy, and XY, that is composition diagram. Such that, on the enthalpy diagram, this equation shows a straight line which passes through the points Q dash ZD at delta D, HFZF at F, Q double dash XW at delta W. So from the enthalpy diagram, the location of F represents the feed is to be liquid below the bubble point. Now let's locate F first. Then on concentration line, let's locate XW and ZD. Then we can locate delta D, which is vertically on line X is equal to ZD. By calculating Q dash or using equation of reflux ratio equation. Then let us extend line delta DF to X is equal to XW to locate delta W. So that the ordinate of delta W can be used to compute QB. Now, to draw operating curve of rectifying and stripping section. Let's draw random lines from delta D, such as delta DJ. So if we project their intersection point on composition diagram, we get operating curve for rectifying section. As we already discussed in the first part of this video. Similarly for stripping section, let's draw random lines from delta W, such as delta WV. And like rectifying section, if we project their intersection point on composition diagram, we get operating curve for stripping section. This is explained in the second part of the video. We can see that both operating curves intersect each other at point M, which is related to the line delta DF delta W. And this operating curve of rectifying and stripping section intersect the equilibrium curve at points A and B. Now, let's draw steps on the XY diagram between the operating curves and equilibrium curve, which begins at point X equals Y is equal to ZD and is then continued to point X equals Y is equal to XW, where each step representing an equilibrium stage or tray. So that's all about Ponchon Savarit method for the complete fractionator. And this is the third part of Ponchon Savarit method video. In this way we can calculate number of trays for distillation column using Ponchon Savarit method. To watch first and second part of this video, please click the link which is given in the description box. In the next part of this video, we will discuss the another topic. So keep watching. If you like my video, please like, share, and subscribe to my YouTube channel which is Chemical Adda.